Start the recording. We are recording. This is the second part of our factoring lesson for the grade 11 applied students. Okay, so pick up where we left off. Okay, so let's come up with two really good factors. Let's come up with, let's say we have, let's say we have 3x minus 4 and x plus 2. That's two pretty good factors. And then we're going to multiply them together. And that's going to give us, let's see, let's FOIL that out. So that's 3x squared plus 6x minus 4x minus 8. And then that's going to equal 3x squared plus 2x minus 8. So there, we know that. Put that aside for now. Let's just move over. Let's pretend we can't see it. I wish there was a way I could like make a little thing to cover it up, but I can't. So I guess I could highlight it and then color the highlight in solid or something. That's okay. We'll just pretend we can't see it. So the question we're going to have is, so our example actually is, solve for x, and the equation is going to be 3x squared plus 2x minus 8 equals 0. So let's pretend like we don't know those are the factors. How would we find them? Okay, well, you could, if you wanted to, try factoring the normal way. You could just open up two brackets. You don't have to write this down because this isn't the way I'm going to do it. And you know that 3x squared comes from 3x times x. But here's the problem. What are you going to do with minus 8? Minus 8 could be minus 1 and plus 8, or 8 and minus 1. It could be plus 1 and minus 8, or minus 8 and plus 1. It could be minus 2 and plus 4, or 4 and minus 2. It could be 2 and minus 4, or minus 4 and 2. Think of how many things you'd have to try before you got the right answer. I feel like I'm selling you something on late night TV. There must be a better way. And there is. We don't really factor this way when there's that many choices to worry about. And I pointed this out to you yesterday. This is something that when you did all of this multiplying in grade 10, you probably never noticed, but it has to be true that this number times this number has to be the same thing as that number times that number. What's 3 times negative 8? Negative 24. What's 6 times negative 4? Negative 24. That's always true. So if that is true, that's what we're going to use to factor this thing. We're going to break this 2x, or decompose it, shall we say, into two numbers that have the same, they multiply to make the same thing as 3 times negative 8. That's the ugliest 3 I've ever drawn. Let me fix that. 3 times negative 8 is negative 24, right? What two numbers times to make negative 24, but if I added them, I'd get positive 2. Now, I promised you that I could give you some shortcuts for this, like, because most of the time grade 10s just sit there and kind of guess and check, look up at the ceiling, hope divine inspiration gives them the numbers. Can I point out to you that you could make yourself a factor tree, right? You know 24 is, say, well, some of you already, well, you already do know that it's 4 and 6 because we saw it already. But pretend you hadn't seen that. What if you're just blindly wondering what numbers it is? 24 has a lot of factors, but not that many. It's either 1 and 24. Oh, and by the way, since this is a positive, I know the smaller one has to be the negative. So it's either negative 1 and 24, or it's negative 2 and 12, or it's negative 3 and 8, and it can't be that one because that's what we started with. And then boom, that's how you hit it right there. And if that hadn't been it, I'd be stuck. I don't have something factorable if none of them worked. So minus 4x plus 6x. I just decomposed 2x into those two things because they add up to 2x, but lots of things add up to 2x. There's infinite things I could add up to make 2x. Why did I pick those two things? because 4 times 6 is the same thing 3 times 8 is. That is the decomposition method. Isn't it cool? Now, it does have one last trick to it. You have to do something. This step has a name. It's actually called partial factoring. Partial factoring is when you look at something and go, I can't factor anything out of every term here, but I can factor something out of some of the terms. Like, for example, in these first two terms here, I can factor out an x, which gives me 3x minus 4. And then in these two terms here, I can factor out a 2, which also gives me 3x minus 4. Usually at this point somebody says, will the brackets always work the same? Yes, if you're doing it right. If they don't work out the same, once again, you've been fooled by one that doesn't factor. Now, some people have a hard time with the last step. Some people just look at it and go, oh, well, this bracket stays a bracket. And then the other two things that are kind of like leftovers, they make the other bracket. That's true and that works. But if you'd like to know the kind of more elegant way of explaining why this is the two factors, what if I asked you to factor xy plus 2y? How would you factor that? You'd go, oh, I take out the common factor. It's y. Well, what if y was 3x minus 4? Get it? I'm factoring this entire thing out of this term, and I'm factoring this in this thing here out of this term. It's like the thing in the bracket is its own number or its own variable that I factor out. Does that make sense? No? That makes sense to me. Okay, see if you can get your head around it. Anyway, in grade 10, you're done there. You factored. Congratulations. Go to grade 11. This year, what did you learn this skill for? Now we apply it. I'm solving an equation here. This thing times this thing is 0. Because that's what's left over when you factor out the x from here, from these two guys, and you factor the 2 out of these two guys. So you factor the x out, you have 3x minus 4. You factor out a 2, you have 3x minus 4. The 3x minus 4 is now a common factor that you factor out of this term and that term. No, I factored a positive 2 out of these two numbers. All right, anyway, like I was saying, these two numbers we have to check for 0. Number times number is 0. All right, what are the two possibilities here? Well, either this number is 0, or this number is 0, or both. So either 3x is equal to 4, which means x is equal to 4/3, or x is equal to negative 2. And that's it. That's the two solutions for that equation. X is either 4/3, or it's negative 2. Okay? As these get bigger and uglier, we eventually start to not be able to factor them. We have 2 more strategies in our toolbox of things we can do in math. We can use what we're going to learn after the break called the quadratic formula, or we could graph it. Graphing will tell us the answers. If I were to, instead of making this a 0, hang on, go away. What are you doing there? If instead of this thing being a 0, I opened up my TI calculator and I made it a y. Okay, so first of all, oh, look at that. We already have some stuff on here. Let's check the window. That's the good window. Okay, let's go and let's erase that equation. We don't want that equation. Okay, so let's turn this into an equation where instead of it equaling 0, it equals y. 3x, where are you, squared, plus 2x minus 8, and then I graph it. If this is a y, when I graph it, but really it's a 0, hey, on a graph, where is y equal to 0? Y is equal to 0 on the x-axis. So the x-intercepts of this graph are my solutions. Do you remember how to find x-intercepts? You go to calc, and which of these things are the x-intercepts again? The 0. X-intercepts are called zeros. So let's see, what's my left boundary? That's too far over. I want this one. So go to the left of it, enter, move to the right of it, enter. It's going to make a dumb guess, and then you hit enter again, and there's -2. There's one of my answers. Let's find the other one. Calculate. I said calculate the 0, and let's move to the other point. So I'm going to go to the right, or to the left of this other x-intercept, and then move to a right boundary past it, and then hit enter, ignore the guess, and what's 4/3 as a decimal? It's 1.3 repeating. 1.3 repeating is the other answer. That's the TI way. On Desmos, it looks like this. Desmos, you don't even actually need to do a y. Just enter 3x squared. What was the equation again? I forgot already. Plus 2x minus 8, thank you. So plus 2x, so plus 2x minus 8, and there it is. One answer is -2, and the other answer is 1.3 repeating. So obviously when it comes to things like the problem solving questions we're going to do and stuff, and when the numbers get uglier than 3, 2, and 8, we're going to allow you to use Desmos. Just like the last test, I'll have a couple of pages where we ask you to see if you can do this kind of stuff without a calculator, just to see that you understand the skill and you didn't just memorize how to push buttons on Desmos or a TI. But one of the goals of this stuff, actually the main goal of this stuff, is to solve problems. Now, it's actually kind of hard to find good word problems for this stuff if you avoid physics and chemistry. I already told you that in physics, every object that moves under gravity is making a parabola. Even a bullet fired is making a parabola. It's just a really wide one. So every equation that describes the path of flying anything is probably a parabola, is probably a quadratic formula, or sorry, a quadratic equation. In chemistry, changing concentration rates, if there's one concentration that you don't know, but you know your begin and end products, you're going to end up with a quadratic equation to solve it. So those happen a ton. The textbook got pretty clever here, though. This is kind of a cute problem. I like this problem. They have found that this problem here, okay, I'm going to move these guys out of the way. We'll do them next. So we'll just do these 3 questions, then you'll have some work time. So here we go. This is from one of the pages in your textbook. The entry to the main exhibit in an art gallery is a parabolic arch. Sure it is. Everywhere I go, I see these parabolic doorways, don't you? Of course you do. And the equation that models it, or the function that models it, function is just a fancy word that means equation where we use function notation. Remember function notation from grade 10? So height as a function of doorway width is this equation. Height is h of w, width is w. They're measured in feet. Several sculptures are being delivered to the hall in crates. Here's the guy moving the crates. Each crate is a square-based rectangular prism that is 7.5 feet high. The crate must be handled as shown to avoid damaging the fragile contents. And of course, you're supposed to figure out, will it fit? So we need to know if this will fit, and if it will, by how much. So here's the basic problem. I have a parabola. So I have a parabola where I know that the equation of this parabola is height as a function of width is negative 0.625 w squared plus 5w. And I have this crate that I need to fit into this doorway. And let's see, I have this diagram over here someplace. So let's see. There it is. No, that's not it. I just want to copy this same diagram because it's a really good diagram. There it is. So yeah, so I need to know if this crate is right across here, and this is 7.5, and this is 7.5, what's the absolute widest that the crate can be before I know it won't fit in the doorway? That's the basic idea here. Okay, so the height is 7.5. So I'm going to take this thing here. This is height. So I'm going to replace that part of the equation with 7.5. And right there, hopefully you realize, oh yeah, this is what he was talking about a minute ago. These are ugly numbers. We're going to use technology to help us. So first of all, when you're solving a quadratic, you have to move everything to one side. So I'm going to add this and minus that from both sides of the equation. So now it looks like this. And now it looks like everything we've been doing so far. It's an x squared x constant. I could graph it if I wanted to. Now, what does this tell me? It tells me how much the width is. It tells me this unknown number. And if my crate is bigger than that number, it won't fit through the normate no matter how much I try. Okay? So let's see. Okay, well, first of all, let's go to Desmos maybe. We'll use technology to help us for this one. So let's go to Desmos, and we're going to graph, okay, so we'll get rid of that one. We'll graph 0.625, and I'll change this to x, but it actually wouldn't matter. I think it could handle a w, but I'll change it to x squared. And then it was minus, what's that? It worked with w? Oh, it doesn't? Okay, then stick to x. Hello.
Hi, how are you?
Good.
Fun with math, right?
We are. Minus 5x.
Can I speak to Andrew for just a
Sure.
second?
No problem.
Okay, sorry about that.
No problem. Minus 5x and plus 7.5 was the other number, right? I'm not looking at the equation, so I can't see it. So it was plus 7.5, right? So there we go. So there it is. That number there is 2, and that number there is 6. And the fact that these worked out to such nice numbers makes me think I probably could have factored it if I wanted to, and I'll show you how to in a minute. But there it is. There's our two numbers. So go back to the picture we made, and that means that this distance here is 2, and this distance here is 6. In other words, this point here has an x coordinate of 2, and this point here has an x coordinate of 6. So if it's 2 from here to here, and it's 6 from here to here, how wide's the crate? 4. So then I would say, therefore, the crate only fits if it is, I'll say less than or equal to 4 feet wide. And that's it. That's how you can use a quadratic equation to solve a problem like that. Now, the fact that it did turn out to be such nice numbers does mean that I probably could have factored it. Here's how I would have done that. I would have still used a calculator to help me. But here, watch this. This is maybe a little beyond what I'd ever ask you guys to do, certainly on a test. But it's kind of neat to see this way. Okay, what if I notice that all the factoring that was easy happened when the number in front of x squared was a 1? Let's make that number a 1. How do I make it a 1? I divide everything in the equation by this number. So as long as I have a calculator, that's not as hard as it looks. So this number divided by itself is 1. That's why I did it. But now take your calculator and figure out what 5, so clear that, get to a calculator kind of mode here. What is 5 divided by 0.625? And the answer is that's 8. So this is minus 8w. You're probably thinking, surely this won't be a whole number, dividing 7.5 by 0.625. And I'd say to you, don't call me Shirley. It's my favorite joke. And there it is. Boom, 12. There you go. What two numbers times to make 12 and add to make negative 8? You can do it. Two numbers times to make positive. Okay, if they times to make a positive and add to make a negative, what do you know about them?
One has to be positive.
Oh, somebody's saying one has to be positive, one has to be negative. Rethink that. they times to make a positive. 2 negatives for sure. So now it's 6 and 2, -6, -2, and notice what are the answers for that make 0? 6 and 2, 6 and 2. This one could have been done by factoring. I ended up using technology to cheat, but it was factorable. Isn't that cool? All right, so there's the only kind of word problem I had for us today. Guy moving a crate. I did want to do maybe a couple of just other questions. Here's one that's kind of also from your textbook that's kind of cool. This is, by the way, I'm getting all these from 7.5. So you can check that in your textbook later if you want. All right, determine the roots of the following equation. What is the first rule of factoring? What do you always look for first? Are there any common factor numbers here? Now, those numbers may not be easy, like in your times table that much, but you should be able to look at them and tell. What goes into both of those numbers? Well, only one of them's even, so it's not a 2. What would be the next logical thing you'd try? You try a 3. Do you remember the rule for whether 3 goes into a number or not? Sum of the digits. What's 7 plus 5? 12. What's 1 plus 9 plus 2? 12. 3 goes into both those numbers. So 3 goes into this number, so divide both sides of the equation by 3, kind of like the trick I just did on that big ugly equation a minute ago. Divide everybody by 3, and look at that. And 3 goes into 19 6 times, carry the 1. It goes into 12 4 times. Hey, does that look familiar? What do you notice about both 25 and 64? They're both what kind of numbers? They're squares. What do you call this again? Look back at yesterday's notes. What do you call that? Nope, not a perfect square trinomial. Other one. Did you not write it down? You're supposed to write it down. You were supposed to write it down. This is why we write down our notes. It's called a difference of squares. So this factors super nice into the square root of the first thing and the square root of the second thing. And what do you do between them? One's a plus and one's a minus. So if this thing's 0, if 5p plus 8 is 0, then p is -8 divided by 5. And notice that this one will be the same basic thing. It'll just turn out to be a positive, because I'll move the 8 to the other side. It'll become a plus. And there we go. And when this happens to you, when you get an answer where it's the same number, but it could be a plus or a minus, you can save some writing in your final answer and just say, therefore, p could be plus or minus 8/5. And if there's people going, do you want a decimal? Not really. This isn't like the last question where you're measuring something in feet or something. You might actually want a decimal. I'm happy with that as an answer. Simplified fraction's good. And no, we don't really want a mixed number. Improper fractions are better numbers to work with than mixed numbers are. Okay, so there's example 2. And okay, we'll do one more and then I'll let you have some time to play with some factoring yourself. Okay, so here's example 3. Let me move it over to some blank space here. There we go. Come with me, little question. Come. And then, there we go. Okay. Really, this is a good one. This is a tough decomposition question. Can I factor anything out of it right away? No. 4 doesn't go in. It goes into 28, but it doesn't go into 49. Oh, wait a minute. I just noticed something else. What kinds of numbers are 4 and 49? They're numbers, yeah. What kinds of numbers? They're perfect squares. Maybe this is a perfect square trinomial. How do I check? Look back at your notes. How do you tell it's a perfect square trinomial? What would have to be true about the number 28? What do you think? The square root of the 49 times the square root of the 4, those two numbers, doubled, has to equal 28 for this to be a perfect square trinomial. Is that true? Is that a true statement? Is 2 times 7 times 2 equal to 28? Yes. Therefore, we have a perfect square trinomial. So that means this thing, as ugly as it looked, and I was just getting ready to do a big decomposition factoring. Lucky I noticed this. 2x plus 7 squared. How did you know it was a plus instead of a minus? Because this sign and this sign always have to be the same. Equals 0. Okay, and now it's actually easy to solve from there. Square root both sides of the equation to undo this square. What's the square root of 0? Still 0. Minus 7 from both sides. Divide both sides by 2. There it is. Okay, and one more time. If we were cheating and we were allowed to use our technology because we looked at these big numbers and they scared us, so we went to our calculator and said, save me from the big numbers, calculator. And calculator said, I'll handle this. So let's see. We have, what was the equation again? It was 4x squared plus 28x plus 49 equals 0. And okay, oh no, Desmos, you were supposed to graph a parabola. You graphed a straight up and down line. Relax. It's just really big. Big, 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 big. Oh, hang on a sec. I should have made this as, I'm sorry, I should have made that a Y. That's better. Y, there we go. And now zoom in. Go back home. There we go. I forgot that I didn't hit a Y instead of a 0. So there we go. We solved it, and there it is. Notice that a perfect square trinomial only has one x-intercept. How come? Because that's where its vertex is. Its vertex and its x-intercept are the same point. That's kind of what makes it special, what makes it that perfect square trinomial. So there it is. That is the point, -7/2. Because 7 divided by 2 is 3.5. Any questions about any of these cool 3 examples? At the back. You need to say that? Okay, there we go. All right, I'll leave it there. That's all the examples I was going to go through today. So like I said, if we hadn't lost 20 minutes to a fire drill, we'd have probably got through that yesterday. So you can have the rest of this class to work. Let me, first of all, okay, I'm going to show you what it says on the blog here. Blog. And I put on the blog, what did I put on the blog? Actually, I haven't updated it for today yet. Oh yeah, that's it. Today's Tuesday. So the assignment for this section is page 405, 1 to 4, 6, 7, 9, 12, and 14. If there's people still working on page 391, because I never really gave you a whole lot of work time in class for that, so you can work on that first maybe. And then that's it. We won't start a lesson tomorrow. 7.6 we'll save till after the break. So that's it. Okay, let me stop the video. And we're done new lessoning for today.